Hello dear students, now I am going to discuss Cambridge IGCSE Chemistry October-November 2024 paper 42. Number 1. The formula of the molecules A to I are shown in table 1.1. A, B, C, D, there are molecule and their formulas are given. So you are asking, answer the following questions about the molecules A to I. Each letter may be used once, more than once, or not at all. State which of the molecules A to I A is an element with triple bond, and you know nitrogen has nitrogen triple bond. Nitrogen has nitrogen triple bond, so answer will be Z. Number B is a product of photosynthesis. This photosynthesis product is oxygen, so H will be answer. Photosynthesis plant use carbon dioxide and water to produce glucose and oxygen, so here oxygen is the product. And number C is used as a fuel is the ethanol, so B is the correct answer. Ethanol used as fuel. And D turns lime water milky. D is the right answer because D is carbon dioxide. You know carbon dioxide turns lime water milky. Number E undergoes a substitution reaction with alkanes. Alkane reacts with chlorine to form chloroalkane plus hydrogen chloride, so answer will be E. Chlorine alkane reacts with chlorine. Reaction type is substitution. F is a colorless liquid at room temperature. This answer will be B, as ethanol is a colorless liquid at RTP, means room temperature and pressure. And Z is a unsaturated ethene. Ethene CH2 double bond CH2, so ethene contains carbon-carbon double bond, that's why ethene molecule is unsaturated. And number H is 21% of clean dry air. Dry air has 21% oxygen and 78% nitrogen, so here 21% will be oxygen, that means H. And I is a reactant in the Haber process. Z means nitrogen molecule. Haber process reactant is nitrogen and hydrogen. Nitrogen and hydrogen reacts to produce ammonia gas, so is a reactant in the Haber process. This answer will be nitrogen. Number 2, aluminum is manufactured by electrolysis of aluminum oxide. State the name of the main ore of aluminum. You know aluminum ore is bauxite, BAUXITE, bauxite. Bauxite, from bauxite ore aluminum metal is extracted. Number B, Name the substance mixed with aluminum oxide to reduce the operating temperature of the process. Cryolite. Cryolite is used to reduce the melting temperature of aluminum oxide. Number C. Explain why the molten mixture in B conduct electricity. It has mobile ions. Aluminum oxide breakdown to form aluminum and oxide ion, aluminum ion and oxide ion. So it has mobile ions. Explain why the molten mixture in B conduct electricity. Because it has mobile ions, that's why it conduct electricity. Table 2.1 contains some information about process which take place at the anode and at the cathode. Anode and at the anode, oxide ion loses 4 electrons to form oxygen. At the anode, oxidation reaction occurs. And at the cathode, aluminum ion gains 3 electrons, as it is 3 plus, so gains 3 electrons to form aluminum. Complete table 1 is done. And 2, complete table 2 1, write the number of electrons needed to balance the ionic half equations for the reaction at the anode. Here 4 electrons, because minus 2 times 2, 2 times 2 4, negative 4, here 0, negative 4 to 0, so oxide ion lose 4 electron, that's why this will be 4. Write the ionic half equation for the reaction at the cathode. Aluminum ion gains 3 electrons to form aluminum. Number 2, state why process at the anode is an oxidation. Anode, oxide ion lose electrons, so electrons are lost from the oxide ion. That's why this is an oxidation. As electron is lost, this process is known as oxidation. Number 3, oxygen is formed at the anode. Explain why the main gas given off at the anode is carbon dioxide and not oxygen. And anode is made of carbon, and anode is made of carbon, so anode reacts with carbon, anode reacts with oxygen, carbon reacts with oxygen, carbon dioxide is produced, carbon dioxide is formed. That's why the main gas given off at the anode is carbon dioxide, not oxygen, because as anode oxygen is produced, so oxygen gas reacts with anode to produce carbon dioxide. E, state why aluminum is used in food containers. Aluminum is resistant to corrosion, that's why it is used in food containers. Aluminum is resistant to corrosion. Dot and cross diagram of aluminum fluoride. This aluminum first shell 2 electrons, second shell 10 electrons, and is third shell lose 3 electrons to form positive 3. And fluoride ion gain 1 electron to form negative ion. Every fluoride ion gain 1 electron to form negative ion. Number 3, question number 3, sulfur forms 2 chlorides P and Q. Chloride P has the formula S2Cl2, chloride Q has the formula HCl2. Number A, both chlorides are covalently bonded and have low melting point. Low melting point suggests in terms of attraction between particles why these chlorides have low melting point. So there are weak attraction between molecules. There are weak van der Waals force between molecules. As both have low melting point, this means there are weak attraction between molecules, so less energy is needed to overcome this attraction. B, chloride PH2Cl2 forms when sulfur reacts with chlorine. Write the symbol equation for this reaction. Sulfur reacts with chlorine to H2Cl2, so 2 sulfur, I write here 2 sulfur atom left hand side, right hand side 2 sulfur, chlorine 2, equation is balanced. Number C, complete the dot and cross diagram for the molecule Q, sulfur dichloride. So sulfur, chlorine, sulfur group 6 HCl, sulfur forms 2 single bond, so gives 1 electron, 2 electron, and sulfur is a group 6 element, so remaining 4 electron in its outer shell. Chlorine is a group 7, so chlorine gives 1 electron in bonding and remaining 6 electron in its outer shell. So show the outer electron shell only, so remaining 6 outer shell. Here 2, 4, 6. This is the dot and cross diagram for sulfur chloride. Number D, chloride P is converted to Q by reaction with chlorine in a closed system. The reversible reaction reaches an equilibrium. The forward reaction is exothermic reaction, means delta H value is negative forward reaction. Energy, heat is produced. So you are asking, suggest 2 changes to the condition which will result in a decrease in the concentration of chlorine Q at equilibrium. 2 conditions that will decrease the concentration of chloride. So at Q concentration decreases. So number 1, decrease in concentration of H2Cl2. So if you decrease the concentration of H2Cl2, position of equilibrium will move from right to left, so Q will decreases. Or you can write decrease in concentration of chlorine. If you decrease chlorine concentration, equilibrium will move from right to left, so Q will be decreases. This number 1 changes will be decrease in concentration of H2Cl2, or you can write decrease in concentration of P or Cl2. Number 2, increase in temperature. As this reaction is exothermic, so if you increase in temperature, equilibrium will move from right to left, so Q will decreases. These 2 conditions will decrease the Q, I mean sulfur dichloride. Number E1, define the term activation energy. You know the minimum energy that colliding particle must have. The minimum amount of energy that must have among colliding particles, colliding molecules. This is known as activation energy. The minimum energy that colliding particles must have, this is known as activation energy. And number 2, give the symbol for activation energy. Activation energy symbol is EA. This means activation energy or energy of activation. Complete table 3.1 to show the effect, if any, when the condition are changed. Use only words increase, decrease, or no change. These 3 words you can use. Now, change to conditions, effect on the frequency of collision between particles, effect on frequency of collision between particles, and effect on proportion of collisions which have energy greater or equal to activation energy. This is the proportion of collision that have more energy greater than activation energy. So number 1, at first concentration of chlorine is increased. If concentration is increased, frequency of collisions increases, and this is no change or remain constant. Effect on the proportion of collisions that have more energy greater or equal than activation energy. So this only affect the temperature. Now temperature is increased, effect on the frequency of collisions between particles increases, and also more molecules have energy greater than activation energy. That means effect of the proportion of collisions which have energy greater or equal than activation energy also increases. And now a catalyst is added. A catalyst also increases the number of mole which have energy greater or equal than activation energy. So if you use catalyst, effect on the proportion of collisions which have greater or equal than activation energy will be increases. Now the reaction between P with chlorine is a redox reaction. So the oxidation number of chlorine in P and chloride in Q is -1. Use the oxidation number to explain. Sulfur is oxidized in the forward reaction. So here sulfur oxidation number of sulfur goes from +1 to +2. Here sulfur +1, 1 sulfur is +1, 2 sulfur +2, and chlorine -2, 2 chlorine. So 1 chlorine -1. Sulfur goes +1 to here sulfur +2. So oxidation number of sulfur increases. That's why sulfur is oxidized in the forward reaction, and chlorine is oxidized in the reverse reaction. And you see chlorine here -1, here 0, reverse reaction right to left. So oxidation number of chlorine goes from -1, this is -1 to 0. So oxidation number of chlorine increases. That's why reverse reaction chlorine is oxidized. Number 4, silver bromide is made when silver ethanoate is added to sodium bromide. Sodium bromide reacts with silver ethanoate to produce sodium ethanoate and silver bromide. Complete the ionic equation for the reaction by adding the missing state symbols. Silver ion aqueous, this is soluble. Bromide ion aqueous. Silver bromide is the cream precipitate. Precipitate means solid, so physical state will be S. And name a different aqueous silver salt which could be used in step 1. Silver salt aqueous means soluble silver salt, we can use silver nitrate name. That's why this name will be silver nitrate. And use the information in step 2 to calculate the concentration of aqueous sodium bromide. So at first number of mole equal concentration times volume. So concentration will be number of mole divided by volume. So number of mole 0.01, volume 50 divided by 1000. Centimeter cube is converted to dm cube. Here concentration is given 0.01, volume is given 50 centimeter cube. So 50 centimeter cube is converted to dm cube by dividing 1000 and concentration 0.01. So if you calculate, you get 0.2 mole per dm cube. This is the concentration. And number D, state the color of the precipitate which form in step 2. Step 2, silver bromide is formed. So silver bromide is cream color, cream precipitate. Silver bromide, cream precipitate. And E, use the information in step 1 and step 2 and equation 1 to determine the number of moles of silver bromide. Number of moles of silver bromide. Use these values to calculate the mass of silver bromide. So number of moles of silver bromide will be same, 0.01, because silver ion reacts with bromide ion to form silver bromide. As bromide ion is 0.01, so silver bromide mole will be same, 0.01. Now molar mass of silver bromide, silver is 108, bromine 80, 188. Now mass of silver bromide will be number of mole times relative molecular mass or relative formula mass. So if you calculate, you will get mass of silver bromide 1.88 gram. F, name the salt dissolved in the filtrate in step 3. Salt will be sodium ethanoate. Sodium ethanoate. In step 3, you see this is soluble salt, sodium ethanoate. Filter the mixture. Silver bromide will be separated and soluble salt will be sodium ethanoate. Number Z, the recorded mass of the dry residue in step 5 is greater than the mass calculated in E because a step is missing from the procedure. So suggest the missing step, rinsing of residue. Residue needs to be rinsed. So if it is not done, so mass is greater. Name the substance responsible for the greater mass of dry residue. So sodium ethanoate is present. As residue is not rinsed, so sodium ethanoate will be present. That's why mass will be greater. H, barium sulfate can be made by same method but with different aqueous solution. Suggest two aqueous solutions which can be added together to making barium sulfate. So barium chloride reacts with sodium sulfate to produce barium sulfate precipitate, or you can write in place of barium chloride you can write barium nitrate. Sodium sulfate in place of sodium sulfate, and you can write potassium sulfate or ammonium sulfate or sulfuric acid. Number 2, write the balanced simple equation for this reaction: barium chloride aqueous and sodium sulfate aqueous, barium sulfate white precipitate solid, and sodium chloride aqueous. Number 5, alkenes are manufactured by cracking of larger alkene molecules. State the source of large alkenes molecule used for cracking. Source of alkane is petroleum. B. State two conditions needed for cracking large alkane molecules. Two conditions: one is needed, high temperature is needed, and catalyst is needed. When one molecule of dodecane is cracked, 3 molecules of but1 and one other product are formed. So use molecular formula to complete the symbol equation for this reaction. Dodecane, 3 mole of butene and hydrogen is produced, because here 26 hydrogen, so 8 is a 24, remaining 2 hydrogen is formed. And number 2, suggest the type of chemical reaction which is happening during the cracking. Cracking is thermal decomposition, because in presence of catalyst and by giving heat, breakdown of hydrocarbon, this is known as thermal decomposition. Breakdown of a compound by giving heat is known as thermal decomposition. D. Propene will undergo polymerization. Suggest the name of the polymer formed from propene. Propene form polypropene. If ethene will form polyethene, so propene will form polypropene. And 2, draw the part of this polymer molecule to show 3 repeat unit. So this is 1 repeat unit propene, 2 repeat unit and 3 repeat unit, and 2 bond open to both sides. So how is it formed? This is the propene, so this double bond breakdown, this carbon contains 2 hydrogen, 1 above 1 below, and left carbon contains 1 hydrogen is below and 1 methyl group is above. This bond open and this bond open. These 3 repeat unit will be added. And state the type of polymerization propene undergoes. What type of polymerization? This is the addition polymerization. Polyamides and polyester are polymers. Polyamides can occur naturally or can be manufactured. Number A, part of the structure of polyamide is shown. So number 1, on the figure 6.1, draw a circle around one amide linkage. Yeah, this is the CONH. So circle this CONH. This is the amide linkage. Amide linkage this. And then complete figure 6.1. Show the structure of the 2 monomers needed to make this polymer. Show all the atoms and all the bonds in the functional group. So this is dicarboxylic acid. One monomer is COOH, COOH, dicarboxylic acid. and other monomer is diamine, NH2. These two monomers makes this polyamide. So how this? This is dicarboxylic acid and this is diamine. So here OH group will be added, hydroxide group will be added, and with NH one hydrogen will be added. This nitrogen, one hydrogen will be added. So this is the one hydroxide group is added, one monomer. This NH one is given, one hydrogen will be added, this is the diamine. So number 3, name the other product form in this polymerization. Carboxylic acid lost hydroxide ion and amine lost hydrogen ion, so water will be lost. Other product will be water. And 4, state the term given in the natural polyamide. Natural polyamide is the proteins, or you can write proteins. 5, name the type of monomers which are used to make natural polyamides. Monomers will be amino acid. Amino acid reacts to form natural polyamides, proteins. Amino acid are the monomer of proteins. And number 6, one of the monomers which form a part of natural polyamides has 3 carbons. So one amino acid, one of the monomers that form natural polyamide, this means one amino acid. Complete figure 6.3 to show the displaced formula of this monomer. This is given. So 3 amino acid, 3 carbon. 3 carbon contains amino acid, 3 carbon containing amino acid will be 2 amino propanoic acid. And amino acid, same carbon contain carboxyl group and NH2 group. So 3 carbon, 1, 2, 3. Number 2 carbon contains amino groups, so this will be 2 amino propanoic acid. So you will show displaced formula, carboxyl group displaced formula, NH2 displaced formula, and CH3 displaced formula. Means you will have to show all bonds present in molecule. And PET is a polyester. Name the 2 types of monomer molecules needed to make polyester. And polyester needed to make dicarboxylic acid and diol. Dicarboxylic acid and diol made polyester, and dicarboxylic acid and diamine make polyamide or nylon. And now number 2, draw part of this structure of PET polyester which show 2 repeat unit. So one will be dicarboxylic which show 2 repeat unit. So one dicarboxylic acid, and you see this is dicarboxylic acid and this is diol. So this will lost OH group and bond will be open. This will lost OH group, bond will be open here, and diol will lost hydrogen, so this bond open, then this block oxygen, again dicarboxylic acid, again diol, so 2 repeat unit, 1 repeat unit, other repeat unit. This dicarboxylic acid and diol make this polymer.